Good day, students! This is Critical Path Method Video Project, and in this video, we're going to discuss all about project scheduling, finding the critical path on a project network. I will be working in this activity schedule project. We already have here our activity, predecessor, and time duration. And we're going to construct a project network, perform forward and backward passes, determine project completion time, and calculate slack values, and last, state the critical path. I will be using this node invention here, and A here means activity, while T means time, ES means earliest start, and EF means earliest finish, while LS means latest start, and LF means latest finish. And now, I will discuss how to make backward and forward passes diagram. So since A, B, and C have no predecessor, so they can begin as start. Activity D needs A to be completed before it can start. Activity E needs B to be completed, and activity F and G needs C to be completed. Activity H depends on E and F. Activity I depends on D. And last, activity J depends on H and G. Since I and J has no successors, they will go to finish. So here's the network with the activity nodes displaying the letters and times. So let's do the forward pass. Since A, B, and C have no predecessors, so its earliest start will be 0. Since it has 6 weeks to be completed, we will use this formula EF is equal to ES plus T to get the earliest finish, so that on the activity A, 0 plus 6 is equals to 6. On activity B, 0 plus 3 is equal to 3, and for the activity C, 0 plus 4 is equal to 4. And now, activity D needs activity A to be completed before it can start, so since the earliest finish of the activity A is 6, the earliest start of activity D will be 6. And use again the formula to get the earliest finish. 6 plus 2 is equals to 8. And for the activity E, since the earliest finish of its predecessor is 3, we're going to get 3 as our earliest start, activity E, and 3 plus 3 is equals to 6. And since 4 is the earliest finish of activity C, the earliest start of activity F and G is 4. So to get the earliest finish, 4 plus 5 is equals to 9, and for the activity G, 4 plus 3 is equal to 7. For the activity H, needs E and F to finish before it can start, since the earliest finish of E and F are 6 and 9 respectively, and H needs both of them to finish in order to start, then the earliest time they can start is 9. In other words, we're going to get the highest earliest finish so we can start the activity H, which is 9. And to get the earliest finish of H, 5 plus 9 is equals to 14. I here has only one predecessor, D, and it can start at 8 and earliest finish at 13. J has predecessor H and G. Since the highest earliest finish time is 14, the earliest start will be 14 and earliest finish at 17. Since J is the highest earliest finish, our completion time will be 17. Now, let's do the backward pass. Since the project completion time is 17 weeks, the latest finish for the activity I and J will be 17. This means that I and J cannot be completed in longer than 17 weeks. Now, we have the formula for us to get the latest start of each activity. LS is equal to LF minus T. For the activity letter J, 17 minus 3 is equals to 14, so that the latest start of the activity J is 14. For letter I, the latest start time will be 17 minus 5, and that is 12. And for the activity H, the latest start of its successor is 14, so that the latest finish of this is 14 also. And 14 minus 5 is equals to 9. For letter G, its successor is 14, so our latest finish will be 14. And 14 minus 3 is equals to 11. Activity F, since the latest start of the H is 9, the latest finish of this will be 9, and 9 minus 5 is equals to 4. And for the activity E, since the latest start of its successor is 9, so our latest finish will be 9, so 9 minus 3 will be 6. Activity D, the latest start of I is 12, so that the latest finish of this is 12. 12 minus 2 will be 10. Now, C has two successors, the F and G. The latest start time are 4 and 11. As a result, the latest finish will be 4 because at backward passes, the lowest latest start is the one that we're going to get, unlike forward pass. So that 4 minus 4 is equals to 0. Activity B has one successor E with the latest start of 6. So, the latest finish for B is 6 and the latest start will be 3. For the last activity A with the successor D with the latest start of 10, so that the latest finish of A is 10 and the latest start will be 4. The forward pass and the backward pass is now complete. Let's now compute the slack values using this formula. So, the slack for the A will be 4 minus 0 or 10 minus 6, which will be 4. The slack for B will be 3. For C, it will be 0. And for letter D, 4. For E, 3. Letter F will be 0, and for letter G will be 7. H, 0. And I, 4. And the last, letter J, it will be 0. Notes, for example, that activity D can begin anytime between week 6 and 10, and it can finish anytime between 8 and 12 weeks. Now, D can be delayed up to 6 weeks and project can be completed in week 17. Activities C, F, H, and J, on the other hand, cannot be completed at all without extending the project completion time. So, for example, if F is delayed by 2 weeks, then the project completion time will be extended by 2 weeks as well, from 17 to 19. The activity with zero slack are called critical activities, so that our critical path is C, F, H, and J. And that's all for this video. Thank you for watching.
Yeah.